I will now introduce our first speaker, Anne-Marie Andersson. She is a senior researcher at the Department of Growth and Reproduction at Rikshospitalet, and she has for more than 25 years been studying the role of reproductive hormones in the development and fertility and the impact of environmental factors. I welcome you to the stage.
And thank you for the invitation. So I'm going to tell you a little about hormone and also about endocrine disrupting chemicals. And there's an official definition of what is an endocrine disrupting chemical. And this is the one. And it's basically saying that endocrine disrupting chemicals are chemicals or mixture of chemicals that once they enter your body, they can interfere with your endocrine system in a way that is harmful to you and to your children or future children. And I think the key word here is endocrine system. So what are the endocrine systems? Well, the endocrine system is the way that different parts of our body talks to other parts of the body. And that way regulate important processes by hormones. And we have many different endocrine systems, and they regulate very important parts like, for example, blood pressure, blood sugar, our appetite. They may even modify our mood and our behavior. And for reproduction, hormones are essential. And they're involved in building up our muscles and in the health of our bone and how our hair grows. So it's very many different processes in our body is dependent on the proper action of hormones. And there are special times during development, during our fetal development, when the organs are produced. Hormones are also involved in regulating some of those processes. This slide just shows that different organs are developed at different time points during fetal development. And the upper bar, you probably can't read the small text, but that says the central nervous system. And for the development of the brain, thyroid hormone is very important. And for the very first weeks of life, it's actually the mother's thyroid hormone that are important, because the child cannot yet, or the fetus cannot yet produce it. And there's another process that is very regulated by hormone. It's what we call sex differentiation, which also takes place. When you have a baby, the first question you normally is asked, is it a boy or a girl? And usually it's very easy to tell because we look different when we're born. But we don't start out that way. Up until 9 weeks into pregnancy, we look at exactly the same on the outside. You can't see difference between a baby, boy fetus, or a female fetus. And in the following weeks, that's where the magic starts happening, and these changes happen. And these changes that you see in the male fetus is all driven by hormones. If you don't have action of the male sex hormone testosterone during this period, this change won't happen. And this is just what we look on the outside. If we look on the inside, we're actually also completely the same until about 6 weeks into the pregnancy. This is just showing schematically the internal reproductive organs. And we start out with having both the anlage for the female reproductive tracts and the male reproductive tracts. And of course that changes during sex differentiation. And all these changes, especially again looking at the male fetus, is driven by hormones produced by the newly developed testes themselves. And these 3 different hormones are involved in making all this happen. So there are periods in life where hormones are really important for how you end up for the rest of your life. And so what when sex differentiation goes wrong? What if those hormones is not working as they should in regulating this? Well, we know that there are some malformations that we can see already at birth. This is a rather rare, luckily, malformation called hypospadia. where the end of the urethra is not ending at the tip of the penis as it should be. And maybe if you remember from my cartoon that the closure of the penis shaft is happening. And if that doesn't go correctly, you can have this. Another malformation is what we call cryptorchidism. And this is when the testis is not in place in the scrotum at birth. And it could be either one or both that are still not in place. And this is, of course, what we see on the outside. But we know that if we see these signs, it's probably also something on the inside the testis, did not go completely right. And we know that because if you're born with either or both of these malformations, you're also of increased risk as an adult to have both a poorer semen quality and also an increased risk of having testicular cancer. Testicular cancer is a little bit special cancer. It's something we see in relatively young men. But it's actually originates already during fetal development because some cells didn't develop correctly. And then they lay dormant in the testes in the boy until they reach puberty, and again gets a lot of hormones to puberty, and these cells do not function correctly. They don't respond correctly to the hormones you get later in life, and then you develop the testicular cancer. So we see something going on later in life as well. So what is causing this when it goes wrong? Well, we know that there can be genetic defects. If you have a mutation in the receptors that are recognizing the signals from the hormones, you can have some of these. And that's actually through those rare mutations that we know that hormones are so important for these processes. But it's very few cases that we can say this is a genetic factor. Most of the cases we don't know why it happens. And that's why we're looking at, could it be environmental exposures? Could it be maybe lifestyle factors that do this? And that's how we come back to the endocrine disrupting chemicals. Well, the chemicals so far that have been identified as being endocrine disrupting chemicals belong to a certain class of chemicals, what we call organic hydrocarbons or organic halogenated hydrocarbons. I won't bore you with chemical terms. I'm just mentioning this because organic in this name stems back from the time when you thought that this kind of class of chemicals could only be produced in living organisms. Up until 150 years ago, that was the case. We used chemicals like that, but we had to harvest it from the nature, like natural rubber that we could get from trees, or plant oils, or whale oil. That was kind of natural occurring chemicals that of this class. But something happened about 150 years ago. First thing was that chemists realized that you could actually produce simple molecules of this class in the laboratory. And from simple molecules, you could build more complex molecules. And the second thing that happens was that we realized that crude oil, petroleum, actually was a seemingly unlimited source of these simple molecules. And for the chemist, these two things together was like putting a big box of Lego bricks in front of a kid. Suddenly they had tools and the material to build new things out of simpler things. And that was the born of the petrochemistry. And the petrochemistry industry, which started around the start of the 1900s, but really took off in the 1940s, were actually building new chemicals. And it's estimated that somewhere around 80,000 new synthetic chemicals were developed and synthesized since then. And I think we can thank a lot of the petrochemistry from the growth and wealth that we experienced in the Western countries, because it gave us new medicines, gave us a contraceptive pill. It gave us new pesticides, so we could grow crop more efficiently to feed a growing population. And we had cheap materials, so we could suddenly mass produce a lot of things. So a lot of the growth we can thank from this. But it didn't take long until we started using this 40s and 50s. It didn't take long until the first signs that maybe not all of these wonderful new chemicals were good for our environment and were good for us. Reports came in already from the late 50s and 60s, 70s about declines in the population of birds of prey. Part of that was due to a fact called eggshell thinning. We had reports of declines of the population of seals in the Baltics, reports of feminization of male alligators in polluted lakes in Florida. And in many European countries, we could also see feminization of the male fish in freshwater streams. And it built up. So when we reached like the early 1990s, a pattern was shown here. And many of the effects that we could see, many of the observations, seem to be linked to the endocrine systems. And at the same time, in humans, we were noticing that the incidence rates of testicular cancer were going up in most of the Western countries. And this is just showing the Nordic countries. And we see increases of 200%, 300%, or 400% over 50 years. And testicular cancer, in this sense, it's not the most common cancer. It's also not the most deadly cancer because we have quite good treatment for it. And survival is very good. But as I told you before, this is a cancer of fetal origin and probably related to mistakes happening during sex differentiation. And when you see an increase like this, you have to say, what is going on? And such a rapid increase can only be linked to environment or something will change in the way we're living. So putting all this together, actually, the field of endocrine disrupting chemicals only just started at the early 1990s. So that's really not a long time we have had to do research on this. In research of science, 30 years, 25 years is not a long time. So what are these chemicals then? I can just show you some examples here. These are some of the early DDT was one. That was actually what was causing, or at least one of the chemicals was causing the decline in the population of bird of prey. PBB is a flame retardant that we use to things not burning so well. PCB is used very much in building material, in electrical equipment, and so on. This is just examples. DDT, there's many more pesticides that also have been shown to be endocrine disrupting. These are the groups as also very persistent chemicals. So it was very clear very early that these accumulated in the food chain, and most of these have been regulated already in the 70s, 80s. And happy to say that the birds are having it better now, and also the seals in the Baltics. But there are also other chemicals that have been shown to be endocrine disrupting, and all those I show here are not, it's still just examples, but they are not persistent. But they are quite commonly used. And just example, bisphenol A and the other bisphenols is very common in clear hard plastic. It's very often made of a resin made of bisphenol A. Phthalates, the two phthalates I show, phthalates are what we call plasticizers, something we add to plastic to make it flexible and soft. So think about what you have in your home that's flexible and soft. And benzophenone 3 is a new group, or an example of a new group of chemical benzophenones that have been shown to be endocrine disrupting, and these are UV filters or UV absorbers that we use in many products who protect them against UV light. And I'm also showing here just some of our normal hormones, and actually the hormones that we know that belongs to systems that have been affected by endocrine disrupting chemicals. Our estradiol, which is the female sex hormone, testosterone, and thyroid hormone. And of course there are similarities, but they're also very different. And it can be very difficult to say, why is a chemical interfering with these hormone systems? But there are parts of these molecules that look the same, and they might even look the same for the body, and that's why they can go in and interrupt our endocrine systems. There are also another class of chemicals that we know now can be endocrine disrupting, and that's what's called the perfluorinated compounds. They look a little bit different, but they're still hydrocarbons, and they might look a little bit similar, like something our body is used to reacting to, namely fatty acids, and that's also very important for the function of our cells. So where do we find these chemicals? Well, they are in many different products. In food, we can have pesticide residues, usually very low, but they're around. There's a lot of focus on food packaging, because what we put our food in can leak compounds to the food. And also during the processing of food, it goes through different materials. So there's a lot of focus right now on food contact material and to make sure that they don't leak chemicals into the food. As I mentioned, medicines, and I also put here a little bit of a hair or head lice, because sometimes we also treat ourselves with pesticides to get rid of bugs that we're not keen to have. And in personal consumer products, in detergents, clothes, sometimes we put different things in, and these perfluorinated compounds I mentioned, they have this wonderful ability that they're both water and fat repellent. So they're very good as a surface if you don't want them to get dirty. But they also don't always stay there. And of course, then we have the flame retardants that are in all our electrical equipment that we have also in furniture and mattresses, so that they don't, if a fire is starting, it's not breaking out. Actually, in some countries, there are rules about mattresses for children that they should not be flammable, so you put flame retardants in them. And so I think these pictures show that they are kind of everywhere, these chemicals, and it can be very hard as a consumer to avoid them. And I think the best way is regulation, but we can maybe do something before we get to regulation. And also when we go out to measuring people, we find these chemicals inside us. So they're not only in the products. They don't stay in the products. They get into our bodies. This is just some of the non-persistent chemicals. Of course, the persistent chemicals are there as well. And the bars here are just showing if we go out and measure it in samples from normal population, if you reach 100, it means that we could measure it every single sample that we tested it for. And some of them, you can see, are in 80 to 100% of all us. So most of how we know that these are endocrine disrupting is from animal studies. And that's where we can test chemicals directly. It's very difficult sometimes to find exactly the same, or no, to prove the effects in humans. And there are different reasons for that. In animals, we can control the exposure totally. In humans, we don't really know what they were exposed to and how they were exposed. And we can control all the other conditions in animal studies, but in humans, we have to take care they live differently. They were exposed to something else at the same time, which I just showed you we are. And in animals, you studies, we often use relatively high doses, and luckily we are exposed to relatively low doses in humans. So people can ask, well, does it then really matter for humans? But we may be exposed to very low levels of most of the chemicals, luckily, but we do also know that we're exposed to many chemicals at the same time. And we also do know from animal studies that in endocrine disruption, chemicals can work together. So it's the sum of the chemicals that affect the same endocrine system that maybe is causing the effects rather than the individual chemicals themselves. And with that, I would just say, it's not possible to go into all the details on what have been seen, but there are some good reports that also are aimed at policymakers and so on, that talks about this in much more detail. So there's some good literature there. And I think with that, I will say thank you.